Okay, so in this video, let me just show you how to do the bit with the slopes, the two different slope lines, right? The first thing is we're going to do a line that connects these first points here, okay? These are all pretty linear. This is where the light bulb is obeying Ohm's law. It's a largely cold piece of wire, like that, right? So I'm going to draw a line that represents that, right? And then this second region here, I want to draw sort of a best fit line for that second region. Draw these lines nice and big, okay? Now, this line here is going to represent the differential resistance, okay? And that's a different concept from the actual resistance of this line here, okay? If we find these slopes, remember that 1 over the slope of this line, right? 1 over m is r, okay? Okay, so that's going to be our little job here, right? So let's take this line here. Let's assume that it goes through 0, 0, right? Here it's if that's 50, right? What do we got? About 40 and 30 and 20 and 10. All right, so that looks to be about 38.38 volts. And of course it's 90 up, right? So my slope for that first part there, if I figure out that slope, right, I'm going to go 90 minus 0 divided by 0.38 minus 0, right? So basically you're just going to take those 2 points and then whatever these points are here, okay? Whatever those points are there, right? And just do y2 minus y1 over x2 minus x1. Okay, so if I do this, right, I go 90, and this, by the way, is milliamps, right? And this is volts, okay? So that is 90 minus 0, right, divided by 0.38. Okay, and that is 236.8, and that's milliamps per volt, right? Now that, of course, if we did that in amps, that would be 0.2368 amps per volt, right? Okay. All right. Now, if I want to find the resistance from that, the resistance is 1 divided by that, okay? So my resistance is 1 over 0.23. All right, here we go. 1 divided by the answer divided by 1,000, right? And I get 4.2 ohms roughly for that part of the graph, right? Okay. Now if I'm going to look at this part of the graph here, right, I got to read these things off. Okay, so let's find there we go, right? So I'm going to read this point and that point, right? This point is over 0 and up, let's see, 20, 30, what is that? That's about 23 milliamps, right? And then this guy here is over, let's see, that's 2, that's 2.5, 2.4, 2.3, 2.35. Okay, that's what I'm going to say. And then it's up 90 milliamps. Like that, right? And now I can find my slope, right? My slope is equal to y2 minus y1, right? 90 minus 23 divided by x2 minus x1, right? All right. So that's going to look like this. Parenthesis 90 minus 23 divided by 2.35 minus 0. And I'm getting 28.51. And that's milliamps per volt. Okay? And of course that would be 0.02851 amps per volt, right? Right? And now we can find the resistance. Resistance is 1 over the slope, so it's 1 divided by 0.02581. Right, so my resistance is equal to 1 divided by, parentheses, that answer divided by 1,000, right? I'm converting milliamps to amps, right? So that's 35.1 ohms, roughly 35 ohms. Okay. Now again, the reason that we've got a difference, this is the resistance, this is the differential resistance, right? Okay. The reason why we have a difference in these two values is that here the light bulb is getting hotter and hotter and hotter. Okay. Here the light bulb hasn't gotten hot enough to change the resistance. Hope that helps.